All right, hey everybody, this is quarter 4, extra credit part 2. We need the volume up. We need to make sure we're showing all our work on both sides. Okay, we're going to do the left, you're going to do the right. So here we go. A rectangle, tennis court. We've got 7x plus 8 for the length, 2x plus 7 for the width. Which expression represents the, and you've got to be careful here, perimeter. Okay, perimeter means to add all the sides up. So the first thing we're going to do is we're going to draw a picture. The length is 7x plus 8. The width is 2x plus 7. And what we've got to be careful about with perimeter is that there is an opposite side that matches. And remember, with perimeter, we add up all the sides. So we're going to add 7x and 7x and 2x and 2x. In other words, we're combining like terms. That's 7, 14, 15, 16, 17, 18. So that's 18x. And remember, when you're combining like terms, we're not adding powers. So there shouldn't be a square on this. Folks, when there's a square on something, that has to do with area, not perimeter. Okay? And now we're going to add up all our constants. So we've got 8 and 8 is 16. And then 7 and 7 is 14. 16 and 14 is 30. So that is a positive 30. So B is the correct answer. Okay? Okay, now what you're going to do is you are going to have to locate which problem on the cutouts is the same type of problem as the one we're working, and you have to cut it out and paste it here and then work it out. Okay, so if you're listening, what I want you to do is I want you to write right here, I want you to write cut and paste. All right, okay, so let's do number 2. Number 2 is an addition and subtraction of polynomials. And this can be tricky. That's why I wanted you to see this. We are subtracting, but notice it is everything in this parenthesis. So basically, that is the same thing as distributing a negative 1. So we are going to distribute a negative 1 to everything in that parenthesis. So I'm not messing with this. I'm just going to bring it down. We've got 3x squared plus 2x. And now we are subtracting or multiplying by negative 1. So negative 1 times 2x squared is negative 2x squared. Negative 1 times negative 1x is a positive 1x. And negative 1 times positive 1 is negative 1. So we distributed. And now we're going to combine like terms. So let's write this down. Okay, so now we've got 3x squared minus 2x squared. These two terms are alike, and that gives us 1x squared. Okay, then I've got a positive 2x and a positive 1x, and that gives me a positive 3x. And then the only constant I have is here, so just bring that down. X squared plus 3x minus 1. And that's going to be this little guy right here. It's hard to see that minus sign. Okay. Now you're going to find the problem that's similar to this. You're going to paste it over here and you're going to work it out. Okay. All right. Let's flip over to 3. Okay. If you're listening, I want you to draw me a rectangle next to the T3. A sum of 3 consecutive integers. We want to get to the place where when we see the word consecutive, that we remember our foldable about consecutive integers. Okay, sorry, my little camera don't work well. Remember that when we have odd or even, they actually go up by 2s. So the pattern would be the first integer would be an x, The second integer would be an x plus 2. The third integer would be an x plus 4, and so on. Okay? So I need 3. This would be my first one, this would be my second one, and this would be my third one. And notice it says the sum of, so we're going to put those together. Actually, let's do this. Let's write first, second, third, okay, and the sum of. So we've got x, we're going to add that to x plus 2, we're going to add that to x plus 4, and it says the sum is negative 81. So now all we do is we combine like terms and solve the equation. We've got a 1x, a 1x, and a 1x. That gives me 3x. A positive 2 and a positive 4 is a positive 6. Now we have a two-step equation. We're going to subtract 6 on both sides. So I get 3x equals, let's see, this is going to be a negative 87. Now we're going to divide both sides by 3. Keep in mind, we're looking at integers, so when you're dealing with consecutive integers, you should not be getting fractions here. You should be getting integer answers, okay? So you can use a calculator. 3, it's negative, by the way. 3 goes into 8 twice, with 2 left over, 27. That'd be 3 goes into 27, 9. So notice my first integer is negative 29. Now here's the tricky part. Notice this is negative, so you got to be very careful. To get your second integer, we add 2. Okay? So we're going to do negative 29 and we're going to add 2. Notice these signs are different. Technically what you're doing is subtracting, and you get a negative 27. That is going to be your second term. And now you can either go back to the first term and add 4, or you can just add 2 again. So negative 27, we're going to add 2 again. So we're technically subtracting, and we get negative 25 for our third integer. So these are my 3 integers. Be very careful with what the question says. The question here says, what is the largest of the 3 integers? When we are dealing with negatives, the largest is actually the smallest number. So negative 25 is the largest integer. Okay, so the answer is B, and I want you to write the word largest right beside of negative 25. Okay. And last but not least, something that's a little tricky, and let me fill in these. These are minus and negative. We got that here. Okay, so this is inequalities, but they're asked in a different fashion. Okay, this says the solution set of which one of these inequalities contains the number negative 4. So we're going to solve these to figure that out. So yes, we're going to have to solve 4 of these. Okay, and when you cut and paste the problem over here, you're going to need to show your work to solve all 4 of these. Okay, a little bit of work, but you'll be okay. So for letter A, we're going to write this down. 1/2 x minus 1 greater than negative 3. How are we going to solve this? We're going to add 1 to both sides. We get 1/2 x is greater than, and when I combine, I get a negative 2. Now to solve for x, I'm going to multiply both sides by 2 here. That gets rid of this. So now I have an x is greater than negative 4. Okay, so this is the solution set for A. Okay, I'm going to solve this one. 1/5 x plus 3 is less than 2. I am going to subtract 3 on both sides, and I get 1/5 x is less than, and when I combine here, I get a negative 1. Last step, to get rid of that 5 that's in the denominator, I'm going to multiply both sides by 5. So I'm left with 1x or just x. Negative 1 times 5 is negative 5. So this is my inequality for letter B. Okay. Now I'm going to leave a little bit of room here. You'll see why in a minute, but I'm going to come down right over here and I'm going to work out C. 3x plus 7 is less than negative 5. I'm going to subtract 7 on both sides. I get 3x is less than, when I combine, I get negative 12. I'm going to divide both sides by 3. Question, does my inequality symbol switch directions? It does not. Remember, your inequality symbol switches directions when you divide both sides by a negative number. I divided by a positive 3. So the inequality sign does not switch direction. Negative 12 divided by 3 is negative 4. Okay, so that is the inequality for C. Now I'm going to do D. Okay, we're going to subtract 8 on both sides. Negative 17 and negative 8 is negative 25. Last step, I'm going to divide both sides by 5. And I get x is greater than negative 5. Okay, this is the answer to D. Okay, the reason for this problem is because you may think that you should pick A or C because you see the number negative 4 and you see that I'm looking for negative 4. But what you have to realize with inequalities is that this is saying the answer is everything greater than negative 4. Y'all, greater than negative 4 on a graph would be an open circle on negative 4, shaded to the right. Why the open circle? Because it does not include negative 4. So that's not going to be the answer because I'm looking for the inequality that contains negative 4. This does not include negative 4. If there was an equal to bar here, it would include the negative 4, but there's no equal to bar. This means everything greater than negative 4. Okay, this right here does not include negative 4. There's no equal to bar here. It includes everything less than negative 4. So if you're listening, I want you to write less than negative 4. And I want you to cross out C. Okay, so now we're down to these two guys. Okay, x is less than negative 5. X is greater than negative 5. Well, what we're going to do here is we're going to do a number line. Okay, and let's start somewhere you know, like with 0, and that next number on the right would be a 1. On the left would be a negative 1, negative 2, negative 3, negative 4, negative 5. Okay, x is less than negative 5. That would be an open circle on the negative 5, and less than would be shaded to the left. Okay, so open circle on negative 5, and it would be shaded to the left. Does that include negative 4? No, it does not. So this cannot be the right answer. Okay, let's take a look at what this looks like. X is greater than negative 5. Okay, so now at this point, we can probably just, here's negative 5, negative 4, negative 3, negative 2, negative 1, 0. Greater than negative 5 is an open circle on the negative 5, shaded to the right, and remember the shading represents the solutions to this inequality. We have shaded the negative 4. So D contains the value of negative 4. Okay? Make sure that when you cut and paste over here that you solve all your inequalities and you draw graphs to show that you know what the correct answer is. Okay? And then what you can do is right here next to T4, write, I'm done. You all have a great day.